by their angles. So here's A, B, and C. Angles can be named one of two ways. By the specific vertex, i.e. the angle A would be named angle A. Or you can name it by the three vertices that comprise the angle. Make up the angle. So for instance, angle A can be named angle BAC, or you have to have an A in the middle, so it would also be called CAB. Sides can be named one of two ways. By the vertices that define their sides, meaning side AC from point A to point C, or by the lowercase letter of the vertex opposite the side. So AC would be labeled little b. Opposite A would be little a for side BC, and opposite angle C is side AB, which would be labeled little c. So, specific words can be used when we're talking about triangles, specifically right triangles. The side opposite the right angle is called the hypotenuse. The side that's right next to the angle in question is adjacent. Of course, there's opposite. And we have Pythagorean Theorem back from grade 8. So this would be A, because it's opposite angle A. This would be B, and this would be little c. And Pythagorean Theorem is A squared plus B squared equals C squared. We know our trig ratios from grade 10. Of course, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. How do you remember it? Somehow you got to remember it. SOHCAHTOA, maybe? The acronym. Okay, let's try to solve for x here. So, does everybody see here's the angle in question? This would be considered my opposite. This would be considered my hypotenuse because it's opposite the 90-degree angle. So which trig ratio has opposite and hypotenuse in it? Just for reference, I'll write down the acronym SOHCAHTOA. And you can see visually the one that has opposite and hypotenuse in it is sine. So we are going to go sine of 60 degrees is equal to x over 10. How do we solve for x? We would cross multiply the 10 over, and x would be 10 times whatever sine of 60 degrees is. So I'll give you a moment to figure that out. Make sure that your calculator is in degrees mode. You can tell that by having the little D in your calculator. So, anyways, what did you get as your answer? We're going to do the nearest tenth as it says. So this would be 8.7, and it's approximately because we're rounding it. So let's do the next one. We have our angle in question. This would be our opposite, and this would be our adjacent. So what trig ratio has opposite and adjacent in it? Well, that would be tan. So we set up tan 52 degrees is equal to 36 divided by x. Now, in order to get x in its numerator position, we are going to interchange these two around. So we get x is 36 divided by tan of 52. It's the magic of cross multiply. And so then we will now punch this into our calculator. I'll give you a moment to try that. And we get approximately 28.2. All right, so now this one, we don't know anything about angles. We're not even trying to solve an angle. So what do you think we have to use? That is correct. Pythagorean Theorem. This is my C. I don't care which way I label A or B. So I usually label the A, the shorter of the two sides. It doesn't really matter. So 3.92 squared plus 4.90 squared equals C squared. So I will punch that all in, 3.92 squared plus 4.9 squared. I'll give you the intermediate step just for fun. This is 39.3764. And how do I get from C squared to C? I have to square root that. So again, because I'm rounding it to the nearest tenth, I will make approximately signs, and that is 6.3, and that would be meters because it says the nearest tenth. Continuing on, here's my angle I'm trying to find. This is my adjacent. This is my hypotenuse because it's opposite the 90-degree angle. So which one has adjacent and hypotenuse? Well, that would be cos theta. So cos of x, we don't know the angle this time, and that's equal to adjacent, which is 45 over 60. So how do we go from cos x to x? To undo a cosine function, we have to use what's called the inverse cos function. So locate that on your calculator. It's the second function of your cos key. So what you do, it's just like algebra, whatever you do one side, you do the other. Because I'm inverse cosing the left side, I have to inverse cos the right side. So I'm actually finding the inverse cos of 45 over 60. So depending on your calculator, you might have to punch that in first or last. You have to figure that out. And the correct answer is 41.4 degrees. So figure out how to punch that in. Sometimes you have to punch 45 divided by 60 equals, then the second function cos to get the inverse cos function. Other calculators, you have to go inverse cos first, bracket, or your brackets automatically come up, and you go 45 divided by 60. Okay, moving on. This time I'm missing a side. I'm not giving any angle, so this is a setup for Pythagorean Theorem again. Again, this is my C. I don't really care which one's my A or my B, as long as you label them. So x squared plus 40.1 squared equals 68.3 squared. So in order to actually solve this, we need to actually move this 40.1 squared over to the other side. So x squared is actually 68.3 squared minus 40.1 squared. So I'm actually going to square that and subtract. So I'll give you a second to figure that out. So I got x squared equals 3,056.88. So then x is approximately, how do I undo x squared? I square root it, and I get 55.3, and that would be kilometers. Now, if I get a number bigger than 68.3, I know that's incorrect because the largest side should be opposite the biggest angle, which is the 90-degree angle in this case. So, what do we got here? We have an unknown angle. We have the opposite. We have the adjacent. So, what do we have here? We have a tan setup. So tan x is equal to opposite over adjacent. So just like the cosine one, in order to solve for the angle and get down to x, from this step to this step, we have to do the inverse tan to both sides. So again, you have to know your calculator. How do you punch this in? Do you go 9 divided by 15, get the answer, then inverse tan it? Or do you go inverse tan of 9 divided by 15? So rounding to the 10th, it'll actually round up to 31.0 degrees. All right, so here's some more complicated ones. It says here we need to find the distance from B all the way to C, but we're not given very much information. We do have a two triangle set up, so I'm going to actually split this apart so we can see this. And this is 8. So the first thing we need to find is this length right here. So that would be my opposite, and this would be my adjacent. So what would that be? Again, that would be 10. So tan of 60 degrees is equal to opposite. I'm going to call it x. X over 8. How do I get x by itself? Cross multiply the 8 over. So it's going to be 8 times tan of 60 degrees. So punch that in your calculator. And we get roughly 13.9, and that's going to be centimeters. Okay, next triangle looks like this. We have a 50 degree angle, and again, this is still 8 centimeters. We don't know what this is, so I'm going to call it y because I've already used x. So again, that's your opposite. This is your adjacent. So what's that equal to? Well, that has a tan set up, so tan 50 degrees is equal to opposite, which is y, divided by adjacent, which is 8. Cross multiply that over, I get 8 times tan of 50 degrees. So what do we get when we do that? I get 9.5, and that would be centimeters. Does that make sense that I would get a smaller length opposite a 50 degree angle versus a bigger length opposite a 60 degree angle? Yes, so let's answer this question. BC is going to be 13.9 plus 9.5. So let's add that up. And we get 32.9, and that would be centimeters. That's my final answer. Okay. Example 3. It says find the distance from point A, 3, 4, from the origin. I'll give you a little visual. So say this is 3 and this is 4, and there's my point A. They're wanting to know what's that distance there. So can anybody think of what to do here? Well, let's draw a right triangle. What's the distance from here to here? Right here? 3. What's the distance from here to here? 4. So what do you think we do to figure this out? We would do Pythagorean Theorem. But hopefully somewhere in your math career you realize this is what's a 3, 4, 5 triangle. Any 3, 4, 5 is what's called a Pythagorean triple. And there's others. Any multiple of 3, 4, 5 is another Pythagorean triple, like 6, 8, 10. But if you can memorize this, this makes your calculation quick. If you don't understand where I got that from, you use Pythagorean Theorem and go 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared, so c is 5. But anytime you have two legs that are 3 and 4, the hypotenuse has to be a 5. So moving on here, in geometry, an angle is formed by two rays with a common endpoint or vertex. In trigonometry, angles are interpreted of a rotation of a ray. The starting position is called the initial side. The final position is called the terminal arm. These definitions you should know from now on. And if the angle is rotated, the angle of rotation is counterclockwise, then the angle is positive. It's a positive rotation. If the angle is clockwise, if the rotation is clockwise, the angle is considered a negative rotation. So I'll give you a visual of what I'm saying here. So the initial side, an angle is considered in standard position well, let's just fill in these blanks. An angle in a coordinate plane is in standard position if its vertex is at the origin. The origin, of course, is 0, 0. Here's my y-axis and my x-axis. And the initial side is the positive x-axis. So right here, this right here is called the initial side. So if I rotate it counterclockwise this way, I'm rotating it positively. And this ray right here of the angle formed is called my terminal side. So the initial side in standard position is on the positive x-axis. If I go counterclockwise, I'm going positive. If I go the other way, this way, I'm going negatively around. Angles in standard position are always shown on the Cartesian plane. The x and the y axis divide the plane into 4 quadrants. Quadrant 1 is considered from 0 degrees to 90 degrees. I'm just going to label my x and y axis. So this is considered quadrant 1. Quadrant 2 is from 90 degrees to 180. So we're going this way around. Okay? From 180 to 270 would be quadrant 3. And from 270 to 360 would be quadrant 4. So I'm going to actually just label this. So this would be 0, this would be 90 degrees, this would be 180, this would be 270 degrees, and this would be back at 360 degrees. So how would I sketch an angle in standard position? So again, here's my x-axis. It starts at my positive x-axis, and I start rotating until I form an angle at 35 degrees. So I know 35 degrees has to be in quadrant 1. So let's say it's about there. And then I label 35 degrees inside there. Let's just label the rest of my x and y axis. So, what quadrant would 230 degrees be in? Well, 230 is between 180 and 270. So I would make it all the way into the third quadrant. Now this is just approximate, of course. I didn't actually take a protractor and measure it. I'm just trying to say what quadrant it's in. So I didn't actually state that. Quadrant 1, this would be quadrant 3. Where would 310 be? Well, again, we're starting at the positive x-axis because it's not saying it's negative 310. We're going to go all the way around until we almost make it around, say about there. And that would be 310 degrees in quadrant 4.